The sum of the reciprocals of three prime numbers is 887 over 2013. Find the greatest of the three primes. Well, let's first of all just write this out in mathematical terms. So we know that this reciprocal of three prime numbers, I'm just going to call those three prime numbers A, B, and C. So what this is telling us is that 1 over A plus 1 over B plus 1 over C is equal to 887 over 2013. Okay, so the sum of the reciprocals of three prime numbers, and A, B, and C are the prime numbers. So let's first of all just think about what we would need to do. We've got essentially three fractions. Okay, we don't know what A, B, and C are, but if they were numbers, we'd need to get them all on the same denominator. Okay, so in order to do that, we would just multiply 1 over A by BC over BC, right? We're just multiplying by 1, so it doesn't change the value of 1 over A. And then the denominator would be ABC, right? A times B times C. We can multiply 1 over B by AC over AC, okay? And then the denominator would be ABC again, okay? And then we could multiply the 1 over C by AB over AB. And now you can see that when we multiply those all out, we haven't changed the value at all because all we're doing is multiplying by 1. So it doesn't change anything. But now we get each of these reciprocals in terms of the same denominator. So what do we get when we do that? We end up with BC over ABC plus AC over ABC plus AB over ABC. Okay, and we're given that that is 887 over 2013. All right. Well, now we can just write it as BC plus AC plus AB over ABC. So you can see the denominator is going to be the product of the three primes in our reciprocals. Okay. So let's look at the denominator over here and see if we can factor it. All right. I'm not going to circle that because that's not the answer. So let's look at 2013. Let's try to factor it. Okay, 2013. Well, it's not even, so it's not divisible by 2. If we sum the digits, you can see we get 6. So it ought to be divisible by 3. So when we divide by 3, we get 3 times 671. And 671 is a multiple of 11. And I guess the reason I see that, if you can see that if I add the first and last digits, it's equal to this digit in the middle, okay? And that's a hallmark of multiples of 11, particularly three-digit multiples of 11. But also, there's a rule for divisibility by 11, is if you have a number and you add the alternate digits. So let's say you have A, B, C. If you add A and C and subtract the other alternate the alternate digit, so A plus B minus C is equal to 0. If that's true, then it's a multiple of 11. Okay, if it's 0 or a multiple of 11, and that holds for longer, not just three-digit, but say we have A, B, C, D, A, B, C, D, E. Okay, so say we have a 5-digit number. Then the same thing holds. Okay, this is D and this is E. We can add the alternate digits. So this case it would be A plus C plus E and subtract the sum of B and D. Okay, and if that's equal to 0 or a multiple 11, then the whole thing is divisible by 11. Okay. So anyway, this is a multiple of 11, and it's 11 times 61. Okay. So, and 61 is prime, right? So now it looks like our answer is, because we're told that the sum of the reciprocals of these prime numbers is equal to this 8887 over 2013, and the product of those primes should be the factors should be 2013, and 2013 is 3 times 11 times 61. Okay, so 1 over 11 plus 1 over 3 plus 1 over 61 should give us 887 over 2013, and you can test that, and it does. That is true. So our answer, it says ask for the greatest of these primes, and so our answer is 61.